All right, today we are jumping into our next way of solving triangles. So far, we've done SOHCAHTOA, Pythagorean theorem. We did law of sines, and law of sines worked with angle, angle side, or angle side angle. Or yesterday we did law of sines, ambiguous case. Today we're doing our last type of problem. Okay. So far, law of sines is really easy because it's really easy to remember and how to apply it. Law of cosines is also really easy. You have to memorize a formula to get to it. When we take our quiz, I will give you that formula. I won't even make you memorize it. But if you were doing these on your own, you got to look back and forth. It gets a little bit weird. Okay, so to do law of cosines, I always think law of cosines is when you have more sides. If you have a lot of sides, it's probably a law of cosines. Now, there is an exception to that. That one's got two sides as well. But if you have all three sides or side angle side, that's a law of cosines problem. All right, and both of these, you got a whole lot of formulas over here. But they all go back to the same thing. Okay, I'll look at this one right here. If you want to find a side, you square that side length. It's going to be equal to the other two sides squared added together minus 2 times the other two sides times the cosine of the angle across from the side you want. Does that make sense what I'm saying there? Because this is alpha and A. So that's going to be our setup to do this. It doesn't matter if you're doing A, B, and C. You just think, is it the one that go with it or the other angles or the other sides that you're trying to deal with? Okay. This right here is how you're going to find an angle given all three sides. Well, if you look at it, it looks like a big crazy formula. All this formula right here is this thing solved for cosine alpha. So you would start off with A squared, and then you would subtract B squared, and then you would subtract C squared, and then you would divide that whole thing by negative 2bc. And then you would do inverse cosine at the end. Those are our two formulas. That's what we're going to use here. Okay. This one solves for a side using law of cosines. This one solves for an angle. Just a matter of understanding which one to apply and how to punch the buttons into your calculator. If you can punch into your calculator today, we're good. Let's look at example 1. So we are finding beta given this triangle right here. So we're trying to find beta. So ultimately, we're finding this guy right here. It's not a right triangle. No SOHCAHTOA, no Pythagorean theorem. Do I have a power couple here? No, because I don't know any angle. I know all three sides. So if I know all three sides, I'm thinking, yeah, it's probably law of cosines. Okay. It asks us to find beta, so we're going to do law of cosines to find beta. So here's how that formula works. It is cosine of whatever angle I'm trying to find. So it's cosine of beta. And that's going to be equal to a fraction. And again, typing this into your calculator correctly is important. You're going to start off with whatever side is across from beta. So in this case, it's 5 squared. Minus the other two sides squared. So technically, if you look at your formula, we're doing this one right here. Minus a squared minus c squared. So we'll follow that path. So minus 8 squared minus 4 squared. And it's going to be all divided by negative 2 times the other two sides. So 8 and 4. So again, notice that this number 5 is only used there once. That's the side across from it. Once we've done that, it's just a matter of typing it into my calculator. I like typing it in all as once. And so what else would I need to do here to get beta by itself? Inverse cosine. So I'm going to do the inverse cosine of all of that. So here's how I'm going to type that in. Second cosine. You got to be careful here because fractions or the parentheses would be really important. So when I type it in, I'm going to use the fraction button. So again, I used alpha F1 n over d. Then I can type this in. 5 squared minus 8 squared minus 4 squared. And then on bottom, it's negative 2 times 8 times 4. It's these other two numbers used again. We got all of that. We hit enter. Boom. There's my answer. It's an angle, so I round it to 1 decimal place. 30.8 degrees is my missing angle. Kind of makes sense with how we set that thing up. Let's go to number 2. On number 2, given this triangle, we are trying to find B. So this is B right here. Do I have a power couple? That's always what I'm looking for first. If I have a power couple, I'm going to use it. But I've got B, but I don't know 45. And I know 2, but I don't know alpha. And I know gamma, or I don't know gamma, but I know 4. I don't have a power couple. Okay? None of those do I know both of them. But what I do know here is I know a corner. Okay, here's how I describe this. This is a corner. This is a side angle side triangle. I know these three things in a quarter. Side angle side. With the powers of these three combined, I'm going to solve the side across from it. Okay, so if I've got a corner, I'm going to use those three together and solve across to the other side. All right? So we're doing law of cosines. Technically, I am using this formula right here. B squared equals a squared plus c squared minus 2ac cosine of beta. So again, here's how I set it up. I'm solving for whatever side I'm looking for, b squared. It's going to be equal to the other two sides squared. 2 squared plus 4 squared. Looks kind of like Pythagorean theorem to start. And then it's minus 2 times the two sides times the cosine of the angle across from the side I'm looking for. So cosine of 45. There's my setup. Once I've got that, it's just a matter of typing it in. So 2 squared plus 4 squared minus 2 times 4 times cosine of 45 degrees. We take it, we type it in, we hit enter. I get 8.686. Is that the answer to my question? No. What else do I need to do with that thing? Take the square root. Second square root that value. We take the square root of that, we type it in, we hit that enter, 2.95. Okay, so in this case, B is 2.95. And again, I always like to double check in terms of the smallest side across from the smallest angle and so on. You can double check that as you go. It's harder to tell here because we don't know the other angles. Questions here on 1 or 2? Let's go to number 3. So on number 3, I know A, B, and C. A is 4, B is 7, C is 9. With that, try to find alpha on your paper real quick. See what you can do with alpha. Go. So we're setting this up. We are trying to find alpha. So again, I started with the A squared minus B squared minus C squared. And then on bottom, I used B and C. So in my calculator, I'm going second cosine. And then I'm just typing it in. Alpha F1 because I like using the fraction bar. 4 squared minus 7 squared minus 9 squared, all divided by negative 2 times 7 times 9. If you're not using the fraction bar, parentheses play a huge role here. You'd have to put the whole top in parentheses and the whole bottom in parentheses. That's why I use a fraction, so I don't have to mess with it. 25.2 degrees is going to be alpha. All right, now this gets into a little bit weird of a spot. Once I've done that, technically, can you use law of sines? Yes, you could technically because you have a power couple. What is the problem if you do law of sines here? You're going to do inverse sine because you're going to be finding an angle. Okay, and if we do inverse sine to find an angle, what else would we have to do? You'd have to check to see if there's a second triangle. Anybody want to do that? No. Me neither. Okay, and so the rule is this. If you start to solve a triangle using law of cosines, just use it the rest of the time. Okay, so at this case, you want to do law of sines, but don't because it would be annoying because you'd have to check for a second triangle. So then again, you would just jump into your next one, cosine of beta, and then work from there. So it'd be 7 squared minus 4 squared minus 9 squared all over negative 2 times 4 times 9. Get that answer and show it to me rounded once you get there. And we type it in. We hit enter. We set it up just like we showed you. We should have gotten 48.2 degrees. So that is beta, 48.2 degrees. Do I have to do law of cosines a third time? No, don't do it a third time. What would I do to find my last angle? 180 minus 25.2 minus 48.2. Okay, just a matter of setting it up and doing it. 25.2 minus 48.2. I get my third angle is 106.6 degrees. Again, when it's written like this, I really like to check. Biggest angle across from the biggest side, smallest angle across from the smallest side, then you're probably doing it correctly. Questions on 3? Let's try again on 4. We've got alpha is 39 degrees, B is 12, and C is 14. Just looking at that, can we do law of sines? No, you got to do law of cosines. This is a side angle side triangle. What are you going to solve for first based on this setup? You're going to solve for A. Find A. and show it to me once you get it close to it. Round it to the nearest number. We type it in. We hit enter. Boom. I get 78.878. Is that the answer to my question? What would I need to do next? Square root it because I'm finding a side length, and a side length is a squared. And so we take the square root of that. I get 8.88 is my missing number. 8.88. Again, we set that up. We did law of cosines. I could do law of sines. Okay, and 99% of the time, law of sines would be fine here. But that one time you do it and it's not fine, it will be frustrating to you. So I would just continue to stick with law of cosines. So you would do cosine of beta equals the side across from it. So 12 squared minus 14 squared minus 8.88 squared all over -2 times 14 times 8.88. We go ahead and do that. Somebody already get that answer for us. 58.2 degrees. We could finish off by subtracting from 180 to get me my final answer. Questions on what we did there on the front side? Let's try one more on the back side. Try and set up and solve the top story problem on the back side about the airplane. See what you can do. Draw it out and solve it. So when we set this thing up, we've got an airport. We've got one plane traveling 300 miles, and then 40 degrees apart is the second plane. It is traveling 200 miles. Our job is to figure out how far apart are the planes at that time. We're trying to find x. So to do that, we would use x squared equals one side squared plus the other side squared minus 2 times 200 times 300 times cosine of 40. Again, it doesn't matter if it's alpha, beta, gamma. Don't over stress about it. Just know where do they go in the formula. Okay, so as I set this thing up, again, it's 200 squared plus 300 squared minus 2 times 200 times 300 times cosine of 40. You type it in, you hit enter. Boom. That is my answer. That is huge. That's not my answer. I need to square root that. Square root it. Boom. Hit enter. My planes are 195.13 miles apart. Questions on what we did there to solve law of cosines? They are not real tough. It is a very straightforward plug into my formula and solve questions.